Yeah, hello together. Welcome to the Tech Talk number 6. Yeah, you got already a few words about me. I'm leading the pre-sales team, and I will today go with you through one example and talk about how component modeling can help you to build up your product model and manage it over the time. For the today Tech Talk, we will using an example. We picked a smartwatch because that took a quite usual development way. Maybe some of your products have similar. So it started with a very mechanical product, was introduced with some electrical components, and today a smartwatch is more a computer than a watch itself. And what we see in more and more in the development of products is that components develop very individual. So we have mechanical parts, we have electrical parts, we have different types of software parts, and all these have own development cycles. Very often the software is developing ways faster than, for example, the mechanical parts. And that increases more and more complexity and problems to handle all these. And that's where we will talk today a little bit about how our VT technology, component modeling, and some other things can help you to manage these dependencies. We had 2 previous Tech Talks regarding our VT technology and also regarding modeling over time. So if you have not seen that yet, it might be interesting to look into that, because that's 2 functionalities we will see and use in this example here. So let's look at how today very often product models are created. And I have named that now as a monolithic product model. And what happens today quite often is that we start in a very nice design phase, creating, in this example, a smartwatch with the different components. So we can see the watch itself over here, and you will also see the different components. And yeah, based on the discipline, so mechanical components, electronical components, and software components, you can see the different colors. And you can see the different components which fits together to build the entire watch, as well as the smartwatch with the ecosystem around, like the charger, the software, and the server components. And that's what we today very often do in model-based system engineering or some other ways to develop our products. We specify very detailed how our product should look like. And at a certain point in time, we build up our product model in a very monolithic way. That means we lose all the relation to the real life and have no longer the connection to specific components and so on. And the problem is when we do so, we have our development here down, and very often at the end of the development, we create the product model and we sell, of course, certain configurations based on that. And over the time, our product model will change and we create new versions. And many companies I see in the market, they also do not track the changes over time. So they just have the newest version of the product model, and they do not longer have all the old versions to know what exactly was available in a certain point of time when a customer bought the product. And that very often leads to the problem when customer with an old product, a machine component, would like to get some spare parts, updates, or something like that. It's very hard to what is still compatible. Can I install a new version on this product, or is that incompatible with this old version of the customer, and so on. So it's really a problem today to track these changes over the time, and also, yeah, now what type of configuration is available at customer side. And instead of creating a monolithic huge model where all these aspects of the product model is in one part, it makes more sense to break the product model down. And we do that already in the technical area where we do modularization. So we find similar parts across our products. We modularize it to reuse it, to accelerate our manufacturing, and we can do the same for product models as well. So going forward, we will look at the component product modeling. And there are different approaches, of course, how you can cut your monolithic product into sub-products. You, of course, could do it as a kind of disciplinary breakdown, that each area, hardware, electronics, software, gets its own sub-product where they maintain their own relations and rules. And then these will be linked together in a product model. But you also can follow a very realistic component view where you split it down, where you cut it down into the parts you have also available as components, and build up the structure similar to your mechanical or your real-world components. And of course, you can use the same approach to combine several products to solutions or systems. But today we will focus a little bit more on the first area. But the technology behind is the exact same, just in different hierarchical level used. So there are different ways how you can structure that, and that's something which needs to be looked individual into each product, what makes really sense. So it makes not sense to just split something which has no value behind. So some drivers to split your product is, of course, that you need an individual versioning. As introduced, the software maybe changes more often than the hardware. So it makes sense to split these both into separate products, and then you can have an own versioning for the software changes and an own versioning for the hardware changes, and keep them aligned in your product model. You can split it for responsibilities. You could have a technical model, and can have a sales model, and they are linked together, or a hardware, electronic, and software. And of course, reusing components, as we can see it down here, the component B used in different products. That's of course also a reason to build components of your product model, to reuse that, to maintain it once and use it n times in your product models. And how does these components now that they fit together, or that there might be an incompatibility between these components? And when we look at the components itself, and I picked here the electronic and the software component in the version 1, what we can define between these components is an interface. And there are consuming characteristics, and there are some offering characteristics. So each component typically offering certain set of functionality, and each component is consuming a certain set of functionalities. And this is something we can model. So we see here the software offering feature A, B, and C. And we can see the electronic is consuming feature A and feature B. And in the same way around, we can do it the other way around. The electronic is offering certain functionalities, in this case, the power of 50 and the memory of 20. And the software is consuming these, so it requires 40 of power and 20 of memory. So they are compatible, they work together, and we have to find what is the interface between these components. What now can happen is that the software develops. So let's say some smart developers have an idea for new functionalities, and they release a new version. And what can happen is that maybe some functionalities will be removed or replaced by new functionalities, but it could be also that some resource consumption will increase. In this case, the memory usage is increased from 20 to 25. And putting these both components together, you will directly see there are some incompatibilities. So I can't install the version 2 of the software on the electronic version 1. Because it's missing the feature B, which requires this electronic version, and it also offers just 20 of memory instead 25, which are needed. So that way, these both components are no longer compatible. And let's take another development step where also the electronic gets a newer version. So we have to remove the dependency to version B. We've introduced the dependency to version D. Feature D, feature C was removed, and also the offered power and memory was increased from this electronic. So it might be a larger power unit or a larger CPU unit, which offers more power, and that is already this is aligned with the software, which requires 45 and 25. So that way, the system knows again, okay, version 2 and version 3 of the software, they are compatible. And also version 2 and version wouldn't be also compatible. And this information, when we put that into the product model, we can use later on for some nice use cases. And of course, you have not just one component or two components and one dependency in between. We have several components typically in the product, several dependencies. And that's something which needs to be developed over the time. So how the end-to-end development cycle could look like. Starting again in the beginning with our classical development. This way or the other way, you do your normal development from the idea to the release. And while you're doing that, you're already creating the product models. Whenever discipline, an engineer finds a restriction or something like that, it will be recorded in the product model. And this way, you can also already share certain informations, and we come back to that in a moment. So while you're developing it, you're already building up your product model with all the findings you have in the different areas. You have some ideas, some design restrictions. You find during the prototyping some restrictions, and all these will be recorded. Of course, that's the technical model, and you also would like to get a kind of sales view on top, with guided selling. You would like to connect it to different use cases and so on. So that might be some extra view on top. And then over the time, you developing your individual components. So whenever a new development happens in the software, in the firmware or software, for example, you create a new version of your component. And based on the relations we have defined between the components, the system can track which of these combinations is valid and which of these combinations are not compatible. And when we now sell products to our customer, we exactly know at which point in time it was sold and which version was at this point in time available. So we know, for example, this customer 1 got the version 1, 1, 2, 4. And this customer 5, he gets the version 3, 4, 6, 10. And that can help if you would like to update, for example. So a very typical use case, it might be for a service technician. He's on site and he's doing some maintenance stuff, tasks, and he would like to update the software to the newest version. So he would like to check if he can install the version 6 on the old customer machine. And based on this combination we have defined, the system can tell the service technician if this is still compatible or if there are some other components which might be needed to be changed, as we have seen before, that you maybe need a larger electronic component. And we can do that for software, firmware as well, electronic and mechanical components. It can help to do retrofits and so on. So this way we can very easily do these tasks, and the product model can really support over the whole lifetime the different disciplines and areas with the product knowledge. So let's look at one example we have built up. Again, we're using the smartwatch here. And to simplify it a little bit, we're using this breakdown. So we have cutted the smartwatch down into the hardware part, into the electronic part, and the software part. And we have implemented some changes over the time. So there are 3 main releases. It's the initial release of the product. It's a second release and a third release. And of course, while during this time, there happens a couple of changes in the different components. And you can see what is the version of this component. So blue, again, is the electronic component, orange is the software component, and yellow is the mechanical components. And you can see what is the version, what is the change, and what was the release date. And that's typically as how a product develops over the time, and I'm pretty sure you can see that in your product as well. And when we want to implement this now, we can look into the modules and, for example, the firmware. And when we just look at the firmware changes, we can see it was version 3, 4, 5, 6, 7, 8. And we can see here in the timeline the different versions of this component. We can see the different characteristics over here, which relates to the specific features which was introduced. And we can also see the rule set down here, which defines the different relations and combinations which are valid. So that's a firmware model, and as a second example, also the electronic component. You can see it has version 2, 3, 4, and 5, and you can see these different versions here as well with the different dates. You can see again the characteristics used here, which defines here the different functionalities, as well the rule set defined to define the valid combinations. And as a next step, these individual components will be bound together in the smartwatch model. So that means we link these models into this smartwatch model. What you can see over here, it has these 3 subcomponents, but it could be also a deeper structure here. And we're defining a kind of version mapping. That means when you look at this release, for example, at this date, release number 2, you can see it over here. So version 2 is linked to version 4 of the electronic, is linked to version 4 of the software, is linked to version 2 of the hardware. And that's what you can see here as well. So it's a version 4 of the electronic, it's a version 4 of the software, and it's a version 2 of the mechanical component. Sorry. And this way we define the relationship between the subcomponent and the individual versioning, and maybe a higher level module or product which has separate versioning. I know we have prepared a few use cases. For the use case, we're using simple UI, and you can see it here. It's an example API example here. So it's a very simple UI, but it focuses here not on a nice looking UI. We would like to see how the technology can support us in different use cases we have over the time. What you will see here on the left side is the typical configuration. So you have different tabs over here. You have different features and functions here you can select from. And on the right side, you can see the different versions of the components and some information which features are added and removed. Over here, we have some customer configurations we can load just to simulate that we have an available customer here, and we load the configuration of this customer. But first, let's talk about the alignment of disciplines. As we said in the very beginning, when you develop your product, you already will track all the restrictions, all the rules you find during development in the modeling environment. And Let's say you have these possible interfaces available you could put into your product. So it's a cable connection, Bluetooth and plus wireless LAN and LTE. And let's say the mechanical department decides we do not longer want cable connection. Charging will be done with wireless charging. So the the cable connection is something they would like to get rid of because maybe it was some problems with water resistance or something like that. So you would like to get rid of that. So that means the mechanical department will add restrictions to the product model or the subcomponent, which will end up in that the cable connection is no longer available. Maybe the same for the electronic component. So the microcontroller used or the board used offers Bluetooth and wireless LAN. So that's the interfaces, the wireless interfaces the electronic component is offering. That means we cannot have LTE and plus in this smartwatch here. And as a software developer, you maybe now would like to know what interfaces do I need to implement? What capabilities does the smartwatch offer? And you can get this information out of the product model itself by reading what combinations are still available and valid. It can be one characteristic as shown here, but it could be also a combination of several products, several characteristics. And also the firmware team knows, okay, we do not have longer a cable connection. That means we need to support firmware updates over the year. So that way, these different disciplines can communicate and exchange via the product model by just adding all the constraints they found and reading from it if you need some information. And also this information can be used for simulations. So what are the possible combinations available you would need to simulate and test in some prototyping. What of course can happen is that if these models are individually maintained, that you create some rules which are contradicting. So it could happen that one area says, okay, we need this functionality, and another area says we do not offer this functionality. And we can detect this information based on our virtual tabulation technology and our precompiled solution space. We call that a blocked value. That means this is a value which can be never selected in the whole solution space. And we can find these and output this information. That means if there are contradicting rules between mechanical and electrical rules, then we can find that in the modeling environment, and with the help of explain why functionality, we can also help to find the right rules and start discussing and fixing it ways before you maybe go into prototyping or releasing. So that way we can accelerate the alignment between the disciplines and the communication, the collaboration. Another example I would like to show is an impact analysis. So for that, I have pre-recorded here a small example, and that's the example configurator we have seen before in the screenshot. And let's look at the use case. So what happens if I, as a mechanical engineer, would like to remove the power connector from the product? So we're offering wireless charging as well. So maybe we do not need this connection anymore. So I would like maybe in next version 4 to remove this power connector from the product. Let's see how the system can help us with that. So as you see, the different areas, and we now opening the impact analysis screen. On top here, you can see the different versions, and we will select the newest version. And then we will scroll down to the power connector. And we can find it down here, the power connector, waterproof connector we would like to remove from the product. And the nice thing is when we remove that one, the system can tell us which other functionalities will be automatically removed as well, because there's a relationship. They need each other. When we scroll up, we can see the connectivity power connector goes away. That's something we expected. But we also can see we can no longer do firmware updates because there was done before in this implementation of the smartwatch only via the power cable. And if we remove that connector, we can't do that anymore. So that means if I would like to remove that, I have to talk with my software team if we could offer firmware updates over the air. And in the same way, we can maybe consider to remove End+ connection here and see what happens. Okay, if we remove that one, we no longer can offer external sensors to be connected with our smartwatch, which is also bad. So I maybe also need to talk with my electrical team as well, my software team, if you maybe can connect external sensors via the Bluetooth interface. So that way you can really figure out what relations you have between the different areas and what impact it might have on your product if you remove something. Getting to the next point, which is today also often a very time-consuming task, is creating a compatibility matrix. So what software version is compatible with which hardware and electronic. Very often that is a task where somewhere has to run through a bunch of offices, ask people and collect this information. In the best case, it is maybe somewhere recorded and you just can grab that from different documents or something like that. But very often it is a very time-consuming process. So based on our solution space, as an example, as a binary decision diagram, we can use a certain set of characteristics from our solution space and build the possible combinations out of that. Because we have a precompiled solution space, it's just a transformation from the hierarchical representation into a table representation. And this is a UI and part of the UI of our modeling environment. And I have defined I would like to do the export from the version 1 to end of life of my product. And I would like to get the possible combinations of my electronical component, my firmware component, as well as my mechanical component. And as a result, you can see that took a few seconds. I get an Excel sheet with all the possible combinations of my components. So you can see here the electronical component, the firmware component, the mechanical component, as well as the main smartwatch events where you have released the main products. And you can see what combinations are still valid and which one you can combine. That's a nice information and sometimes great to look at, but how can that support, for example, service people knowing what combination can be off, or what software can be still installed on a customer device? And that's what we will look into on the next use case. And we will look into that from two different point of views. The first point of view will be, can I update a customer to a new firmware? So imagine we are a service technician on site at customer side. We've maybe done some maintenance on the product or something like that. And we see, oh, this customer is running a quite old firmware version. And we would like to update this customer. Today, I expect in most, in very often cases, the service technician needs to know what is compatible, what he can install. But the system can support here. So starting the recording, we can load here a customer configuration. And you can see the customer has the version 2.4.4 available on site. You can see the different selections available for this customer. And you can go into the firmware version and you can see what combinations are still valid and which version would be invalid with the current software. And of course, you can go the easy path by just selecting one of these which are compatible. So let's say version 7. So you know version 7 is still available and compatible for this older version of the customer. So you can install that very safe. But you also can check what do you need to change in the product to get to the newest version, because in future version 9, 10, 11, they also will be no longer compatible with this old machine. So maybe you would like to offer your customer some retrofit, some modernization of the product. So you could ask the system, okay, let's update to the version 8, and what else I need to change. And that's where our conflict solving comes into place. So by assigning version 8, I can see what is incompatible, and I can see here also the electronical component is incompatible. And what happens now is that it is updating the component to version 5. And I also can see what new functionalities a customer will get based on this update. So if the customer will update to version 8 and also the electronical component to version 5, he will get all these updates for the product. So he can, for the smartwatch, now play music, he gets mobile notification, blood oxygen tracking, he gets the connectivity with LTE, a better microcontroller, and yeah, of course, the blood oxygen sensor for the data tracking over here. So these are the changes. That means I can also very easily tell a customer what benefits he gets when he updates to the newest version. So that's one way. I'm a service technician on site, and I would like to update to a newest version, and maybe also tell the customer what benefits he gets if he makes a retrofit or modernization of the machine. The other way around might be that the customer would like to get a specific functionality. So let's say a customer bought these products 5 years ago, and meanwhile you have some new nice functionalities. He would like to be interested, but he don't want to buy a complete new machine. So he might ask you, hey, what do I need to do to update to get this new functionality? And that's the other use case. We're using the same UI again, loading a different customer configuration. And you can see that one here is on version 1.1.2. And now we go down here and look at the functionalities. And this customer would like to get music playing for the smartwatch. And you can see for the current versioning he has, it is grayed out. So it's no longer available. Compared to that one here, you can see it's black, that one's gray. So that means playing music is not available for the current configuration or for the current version he has on site. But again, we can use the conflict solving here by selecting the play music, and the system will tell us what is in conflict. So by selecting music, I have to change the electronical component as well as the firmware component. And I say assign that, and I can see now the update. So the mechanical part can stay. The electronical part is updated to 4, and the firmware version was updated to the minimum version 5, but you can also install a higher version. And you can see also what else on functionalities the user will, the customer will get additionally to the playing of music. So he gets also tracking of data, of steps. He gets connectivity with wireless LAN, mobile notifications, a waterproof connector based on the new electronic and the connector, some new sensors, and so on. So that way, you can support also these use cases to figure out what is it, what I need to change to get the new version and this new functionality here. So that was some use cases which can easily be handled if you model the product in the right way, if you use component modeling, if you maintain the separate versions of your components as it is today, the different components are developing in own cycles. And when you track that, you can easily handle such type of problems. So that was the prepared content for the Tech Talk today. So when you combine our CLM approach, having one configuration engine, handling over the whole life cycle of your product. If you define your product in more granular components, you can track the different versions of your components. And with the help of our VT technology, you can easily handle these type of use cases. So you can align better between disciplines. You can simplify your version management. You get the one-click compatibility matrix. You can do the impact analytic, as we have seen before. You can simplify your customer update handling. And of course, you have a dependency management between these different components. So you also could see in the modeling environment, for example, if a component A is reused in 10 or 20 other products, you can really see where it is used and to know which products you might affect with a change. Yeah, so that was the tech talk about component modeling, and I'll maybe hand over back to Jörn.
Thank you
for some questions.
Thank you, Heiko, for delivering this very interesting presentation. So, how does all this play together with the BOM structure in PLM?
Yes. Of course, it depends a little bit on how you split your product model. So what approach you use. If you split it more in a disciplinar view as hardware, software, and so on, it might be just an organizational split. So it might have no connection to the BOM itself. But if you go with a very modular-driven approach and you cut it down into your specific modules, it can be zoomed between the PLM system and the ACE modeling environment so that these structures are somehow in line. If you would like to know a little bit more of how the configuration and the BOM structure can be connected, there was a tech talk, I think it was number 3, which talks about this topic.
Can I access all this information only via the Configit UI? It is being asked.
Yeah. So the answer is no. You can access this information from any application. So we have an open API. So you can access the configuration and the knowledge we have seen here, the compatibility matrix, for example, or which selections are still compatible, the conflict solving, and so on. All these things are available in our API, and you can access this information from any application. So it could be a self-service customer portal, it could be some service application, it could be a web shop, so you can integrate it into any application.
Can I import an initial structure from an MBSE tool? I think that stands for Model-Based System Engineering.
Yes. So we can import this information. So we have also an open API when it comes to import modeling data into the product modeling environment. So we can import this data. We do not have a standard interface for that yet. But if this information are available, then typically behind there is a very structured representation. We can import this information as a first design BOM or initial structure of the product model, and then you would extend the product model with the characteristic rules and some other information you might not have in your model-based system engineering tool.